So today's lesson is 5.2, solve linear systems by substitution. And the goals, or the one goal, is to solve a linear system of equations, this time by substituting a variable from one equation, so from equation 1, into a second equation, equation 2. So here's an example. When you're starting with an equation, the first thing you should do is label the equations. So this system has two equations. This will be equation 1, and this will be equation 2. And what you're looking for is you're looking to see whether or not there's a variable isolated already. So I can see that the y is isolated. It doesn't matter if it's x or y, but here's a y that's isolated. So what we're going to do is we're going to substitute equation 1 into equation 2. So when we do that, you start by writing equation 2, 4x minus 3, but instead of writing y, we're going to leave space equals 1 because we're going to put equation 1 in there. So y, according to this, is equal to all of this here. So negative 2x plus 3. If you look at this equation now, it becomes a simple equation with only one variable. We just have to be careful that we remember how to solve using the method where we draw a line down the middle and we distribute and we collect like terms and we simplify and do all of that. So here I'm going to distribute the negative 3 that's in front of the bracket, but I'm going to copy the 4x and everything else that should stay the same. So the 4x should stay the same, equals 1 should stay the same, but when I distribute I have negative 3 times negative 2x, that's positive 6x. I have negative 3 times positive 3, that's negative 9. Okay, now I'm looking to collect like terms, so I recognize that this negative 9 here should be moved to join the 1, and 4x plus 6x are already together. So 4x plus 6x, no moving. The 1 doesn't move, but the 9 moves, so it becomes positive. So now I have 10x equals 10. If I divide both sides by 10, get x equals 1. So if you remember with the graphing method, the answer should be a point. So x equals 1 is not enough. You now have to take your answer, x equals 1, and we're going to sub x equals 1 into one of the equations, whatever one's easier. So I'm going to sub it into equation 1. I think that one's easier. So y equals negative 2. Okay, leave a space where there should be an x, plus 3, and substitute the number 1. So now y equals negative 2 times 1, which is negative 2, plus 3, and y equals negative 2 plus 3, which is 1. So the answer here is that x equals 1 and y equals 1. The solution to this linear system of equations is 1, 1, the point 1, 1, point of intersection right here. So if I were to draw it out, this is what I would get. Let's try another example. In this example, we still have equation 1 and 2. Equation 1, equation 2. However, none of the variables are isolated. So what I need to do is to choose one of them to isolate. So why don't we use this first one? Here's a y. We're going to move this 2x to the other side so that we get y equals 4 minus 2x. Sorry, minus 2x. Okay, so now that's going to be our equation 1. We have an equation 2. So we start by deciding, now that we've isolated y, we're going to sub equation 1 into equation 2. Let me copy down equation 2. 4x minus, leave a space for the y, equals 2, and in that space I put equation 1, and 1 says that y equals 4 minus 2x. Now we go on to solve. Draw a line, distribute the negative sign, copy the things that don't need to change. So the 4x is not changing, equals 2 is not changing. But the negative, you can even actually put in a negative 1 if that helps. So you remember, it's negative 1 times 4, which is negative 4, and negative 1 times negative 2, which is positive 2x. Okay, now we group together like terms, so I need to move this 4 to the other side. This one here has to be moved to this side to join the 2, and we will collect like terms, simplify, and solve. So what's left here is 4x plus 2x, and on the other side we have 2, and now we have a positive 4 as well. So 4x plus 2x is 6x, 2 plus 4 is 6, so it just happens to be that if I divide both sides, I end up with x equals 1 again. So part of my solution, remember it's a point, is 1 comma something, but we're going to need to sub our answer, x equals 1, into one of the equations. So I can choose any equation I want. So why don't we pick equation 2 this time? Okay, and if I do that, it's 4, leave a space for the x, minus y equals 2. Okay, and the goal here is to find out what y is. So if I put in my x value, 4 times 1 is 4, minus y equals 2. So at this point now I need to isolate y, because I need to solve for y. So I'm going to move y to the other side, and it becomes positive y. So that's just a trick that I think will help me save time. So I'm going to move this y to the other side, but then I need to move the 2 here to join the 4. So those 2 switches and I will be done, because 4 is already there, positive 2 becomes negative 2. So y equals 4 minus 2, which is 2. So the answer, the point of intersection for this system, is 1 comma 2. There's my point of intersection. Okay, and just something we're going to discuss in class, being able to talk about linear systems, so being able to describe the steps you would use, and comparing, is this system, how is this method different than solving? Because so far we've learned two methods, solving by graphing and solving by substitution. Okay, and are there any advantages? Do you like this method better, or do you not like this method? So consider all of those questions, and we'll talk about them in class together.